Good morning, geometry class. I can't believe it, but we are in our last lesson of PACE 1120. And so I'm so proud of each and every one of you. You've done a wonderful job. And I'm just so glad, and even in spite of all of this, the difficulties and obstacles, you guys and girls have done a wonderful job in sticking with it, working hard diligently. And so I'm so excited. I hope you're excited as well as you complete geometry. So we're going to quickly pray, and then we're going to review last night's lesson. I had a little bit of trouble trying to map those shapes on the board. We're going to try to retry that with you. At least you get those techniques down. And then we're going to get into dilations, and we'll finish the PACE with dilations. You'll have to take the checkup today, so you'll take the third checkup today. Be sure that is in by 3 o'clock. If it's not in by 3 o'clock, you'll be deducted 10 points off of that for every hour that you are late. And then tomorrow, be prepared. We'll be taking the self-test. So make sure you're being prepared for that. Again, you can see as you prepare for the self-test, all you're going to be doing is all of our transformations. So reflections, rotations, translations, glide reflections, dilations, all those things that we've done, you'll be doing those on your self-test. If you get received an 85 or higher, you will not have to take the PACE test. So be sure you get that in. That'll be Thursday, and then if you have to take the PACE test, that will be Friday. All right, so let's pray, and then we'll get started. Lord, in all of our civil unrest that's going on in our city with the rioting, protect our families, each and every student. Watch over them. We ask that you give our leaders wisdom, direction. I pray that you would just intervene in all of this. Give us wisdom tonight, today as we finish this last math class. The students, to Lord, give them wisdom, alertness. I pray they work hard and diligently in this matter. And we'll thank you and praise you for all that you've done. In Jesus' name, amen. All right, pick up on page 34. Again, 34, I have number 2 on the board, and we're going to quickly look at number 4 on the board. So again, we're going to just kind of do some easy steps here to remember what we're doing. So the first thing we do, we want to draw a line segment. So you want to connect the line segment. So from A to A triple prime. So first thing we do, again, this is number 2 on page 34. So draw a line segment from A to A triple prime. Once we do that, now what we want to do is we want to form a perpendicular bisector. So how we do that is simply, we're going to stick our compass point on the end point. All right, A triple prime, open it up a little bit more than halfway. Kind of strike an arc there. All right, stick our compass point on A. Kind of do the same thing. All right, so once we do that, let's draw our perpendicular line there. So I'm going to quickly connect those points there. Now, what we've just drawn is the line of reflection. So now we've already reflected A to A triple prime. Now we're going to reflect B and C. So again, you want to make sure the distance, we preserve the distance there. And then what we want to do is make sure that our line is perpendicular. So let's quickly measure here. All right, so 6.5. So we're going to go, all right, let's see, let me make sure I measure that correctly. All right. Okay. All right, so now we have B. I'm just going to call that, since this is B original, we're going to call this B prime. And then I'm going to do C as well. So we're going to bring C over here. So C is, okay, so we have C prime there. All right, now I'm going to form my triangle. So A to C, okay, C to B, and A to B. Now I'm going to use a different color marker just so you can see here. Once we've done that, all right, so we're going to repeat the same 3 steps again. So now I'm going to draw a auxiliary line from B to B triple prime. Okay, I'm going to connect those 2 points there. I use a pink marker. so you can see. Then I'm going to get a perpendicular bisector, and we're going to get a perpendicular bisector for line segment B, B triple prime. All right, open a little more than halfway. Try this the best I can here. All right, and then come to, all right, be there. All right, once we do that, now class, I'm going to just draw my perpendicular bisector. Let's use pink since we're going to use this triangle there. All right. Once we do that, okay, now what we want to do is we're already reflected B. Now we're going to reflect, obviously you can see here, all right, we have C, and A is already a corresponding point. So A is already on the line of reflection. We've already reflected B, and now we're just going to reflect C, which is right here. Now here's what you're going to notice now. If I connect my line segments, we mapped it on. So we can prove that this triangle ABC is congruent to triangle ABC triple prime, because by mapping we're able to prove that it maps right on top. All right, let's look at down number 4 here. We'll do number 4 together. All right, so again, steps are, repeat the steps. So let's use, this time I have a brown marker. So I'm going to connect my line segments here. So A to A triple prime there. Okay, then we're going to form a perpendicular bisector. So once we get our compass here, all right, got to open up, try to open up. All right, let's see here. I guess that's a little more than halfway. All right, and then come here, open it up. My marker is struggling here. All right. There and there. Okay. Now, once we've done that, what we want to do is draw our perpendicular bisector. So we're going to quickly... Okay, this now becomes our line of reflection. Now we're going to reflect points B and C onto... All right, across the line of reflection onto this side. So let's quickly map B. Again, making sure your lines are perpendicular. I just want to make sure that I, all right, here. Oops. Let me make sure I get this accurately. All right, so we're going to call this B, B prime. All right, now we're going to do point C as well. So we'll go C, 5. All right, C prime. Now, what we're going to do is just connect my vertices here. All right, so we're going to go, obviously, A to B, B to C, and A to C. Now, once we've done that, we're going to take our compass again, and now we're going to, take our straight edge, excuse me. We're going to use the pink marker for here. Actually, we'll use the green marker just so we can see. Now I'm going to connect point B to B. So B to B triple prime. So B to B triple prime. Okay, there we go. Now we're going to get our perpendicular bisector there. All right, so get our compass out. Perpendicular bisector, stick that on our point B there. Open the line more than halfway. Struggling there. All right, come to here, this point. All right. Now let's connect these line segments. Let's connect this line segment. Now, this becomes my line of reflection right here. So, B made line segment to B triple prime. Okay, now that this becomes our line of reflection, now I want to reflect point C across. So I get my ruler here. All right, point C. So let's go from here. Point C is, excuse me, I got my ruler. All right. So point C, we have 4 1/4. I guess right about there. So 4 1/4 would be 8.5. All right. Let me just straighten this out a little bit. I want to make sure that these lines are perpendicular. Okay. Let me just make sure they're perpendicular here. All right. So we have C double prime. All right, so reflected B across, reflected C across. Now notice A is right there. So we're going to connect. Notice we have A to B, B to C, C to A. So we reflected it once, we reflected it twice. Now we're going to map it onto A triple prime, B triple prime, and C triple prime. So in order to do that, so I'm going to connect C here, find a perpendicular bisector, which we already have the perpendicular bisector there. So C is mapped, B is on the point, C is on the point, or A is on the point. All I got to do is connect A and C. And again, you notice, mapped it right on the triangle. And there we have, we could say that triangle ABC is congruent to A triple prime, B triple prime, and C triple prime, simply because of mapping. So able to use isometries to prove triangles congruent. So just continue repeating those steps. All right, let's look at page 35. Page 35 now, and we didn't do this last night, so we'll quickly do it right now. Page 35, what we need to do is determine what type of isometry. We've learned thus far reflections, we've learned translations, we've learned rotations or glide reflections. All right, so is needed to make the two figures coincide. Looking at number 5. Now notice as number 5, all the points correspond. They're not reversed, so it can't be a reflection. All right, it's not rotated, so we know it's not a rotation. So it looks like it just moved across the page. So for number 5, what will we have? A reflection, a rotation, a translation, or a glide reflection? A translation, very good. Number 6. Now notice the object looks like it's flipped, correct? So if it would be as if we were looking into a mirror. So although the shapes are identical, again, the orientation is different. So we would say for number 6, is that a rotation, reflection, glide reflection, or a translation for number 6? Good, a reflection, excellent. Number 7, we have, all right, it looks like for number 7, we have the shape, and notice where the two shapes, all right, coincide here. They share a common vertex, so we would call that the point of rotation there. And so we would say for number 7, we would have, what type of isometry? A rotation, excellent. Number 8, again, we see the shapes are sharing a common point. So that fixed point is called a point of rotation. So for number 8, we would have, what type of isometry? A rotation. Very good. Number 9. Again, now looking at this shape here, okay, let's see. Obviously, all the points are coinciding. Notice it looks like it's just sliding down the page. And so would that be a rotation, reflection, glide reflection, or a translation? Good, a translation. Excellent. Number 10. We would have a reflection. Excellent. Number 11. Now notice the object has slid across the page and is upside down, the orientation. So that would be a what? A glide reflection. A glide reflection. Good. Number 12. Number 12, we simply have a translation. Excellent. The shapes are both in the same, facing the same direction. They both have the same orientation. The shape is just simply sliding across the page. And number 13, we have a glide reflection. Great job. Page 36. Page 36, looking at a dilation. Page 36, looking at dilations. All right, what we want to do is we want to make sure that we highlight. We want to highlight what a dilation is, and so when we get there, make sure you highlight that. But again, we've all had pictures taken, school pictures and everything, and once you get your pictures taken, you get a packet, right? And you pay for a packet of pictures, and inside that packet, you get various sizes of pictures. You get an 8x10, you may get some 5x7s, right? You may get some wallet-sized pictures, and so we have big pictures, we have little pictures, and so we see the enlarging and reducing of those images. That would be called dilation. So photography, pictures, enlarging them and again, shrinking those photos, reducing those photos is a good example of dilation. The transformations that we have discussed so far have been isometries. Now remember, what's an isometry? You should know this, it's a highlight. It is a distance preserving, very good, it's distance preserving. So as a result, right, the properties of collinearity, betweenness of points, distance, angle measures, they all apply to these isometries. Now, let's look at the different type of transformation, our last type of transformation. This is a dilation. So we see a dilation is not an isometry. Okay, very important here. A dilation is not an isometry. What does that mean? All right, so we're not going to preserve distance. We're not going to preserve distance. So the image is not congruent to its pre-image. This whole pace, right? We've been talking about isometries. And so the triangles and squares and rectangles and parallelograms, all that we've done have been congruent to the pre-image. Now for a dilation, we're going to see that we're not going to have congruent figures. I want you to highlight what a dilation is. A dilation is a transformation with a fixed point O and a positive real number K that maps each point in a plane to an image. And so if you look at figure 7 and if you look at figure 8, you'll notice you have O, okay? Point O. So O is going to be the center and K is called the scale factor. And you say, well, what's the scale factor? Well, K will tell us whether we're going to enlarge the shape or if we're going to reduce the shape. And so that'll give us a number, whether we divide it by that number or if we're going to reduce it, or multiply it by that number if we're going to enlarge it. The value of the scale factor K is what causes a dilation to result in an enlargement or a reduction. A dilation is an enlargement when K is greater than 1. All right, so if K is greater than 1, so if K is 2, or K is 3, or K is 4, we would have an enlargement. If K is less than 1, then we would have a reduction. So if you look at figure 8, okay, figure 8, we see, notice how the size of the figure is reduced when K equals 1/2. So actually figure 9 right below here, you see we started off with a larger shape. And since K is less than 1, notice that the shape was reduced. Now you might ask the question, how do we get the measurement so we know how far to move those various shapes? And so looking at the last paragraph here, to form a dilation, begin with the figure, in this case triangle ABC with center O. And the scale factor is 1/2. All right, so basically, okay, let me get there. I'm going to draw this. We have A, B, C. And we're going to call that point O. Okay? We have point O. Now, we're looking at here the figure to the left-hand side of that page. Okay? All right, so first thing we're going to do, we're going to form rays. So you're going to take your straight edge when we get to them, but you're going to take your straight edge and you're going to connect these vertex, right? Each vertex to point O. Okay, see how I connected each one to point? That's the first thing you're going to do. So step 1, draw rays OA, OC, and OB. Once we do that, now notice K for this problem is 1/2. So that means we're going to do a reduction. So here's how we do this. We're going to measure each ray. Once we measure each ray, we're going to find out what the distance is, and then we're going to times that by 1/2. Okay? So let's see here. We have OA is, I'm going to say, all right, we're going to say 12. So at 6 inches, all right, remember, so what's 12 times, 1/2 times 12? Okay, so we have 6. So right at 6 is where I'm going to put my image. So right here. So we're going to call this A prime. All right, now let's measure OB. OB we have is 10. So then 1/2 times 10, right, would be 5. So at 5, we're going to put point B. We're going to call this B prime. And then we're going to measure point C. So again, we're going to say, just say for sake of 12. So again, that'll be at 6. All right. I'm going to call that C prime. Now I'm going to connect my line segments, forming my triangle here. Okay, you notice here our triangle. Notice it shrunk. We reduced it. That is a dilation. So we went from a triangle ABC to a triangle A prime, B prime, C prime, and we simply used our ruler and then the K as our dilation. Now let's look at number 5, 6, 7, 8, 9, and 10. And we're going to go on and we'll practice a couple of these on page 37. Number 5, right? Using the figure below, find the missing value if K is the scale factor. So in number 5, all right, if line segment or ray OA is 2 and OA prime is 8, what is K? So if we went from 2 to 8, what would be K? Now, if you wanted to do, obviously figure that out mathematically, we would say, right, 2x, right? Or we could say 2k equals 8. If we divide both sides by 2, k would be what? 4. Very good. Because 2 times 4 equals 8. You get it? Look at number 6. If OC is 5 and OC prime is 15, k would be what number? All right, so we can go 5k equals 15. Divide both sides by 5. K equals 3, right? Because 5 times 3 equals 15. Number 7. If OB is 3 and OB prime is what? K is 3. So OB is 3 and then OB prime. What is OB prime? So what's the longer line segment? If OB is 3 and K is 3, what would be OB prime, the longer line segment? It would be 9. Very good. 3 times 3 gives me 9. Now how about if OA, all right, let's do a reduction. If OA is 8 and OA prime is what if K is 1/2? OA is 8. OA prime is what if K equals 1/2? If K equals 1/2. So 1/2 times 8 equals what? 4. Excellent. 4. Number 9. OC is blank. OC prime is 6 and K is 1/3. So simply 6 times 1/3 gives me line segment OC. So 6 times 1/3 simply gives me, all right, let's do that together. Okay, 6 times 1/3. 6 times 1/3. All right, that would give me what? It would be, not be 6 times 1/3, right? It would be 6 equals 1/3 times OA prime. So we just simply, right, we're going to get rid of the fraction, correct? So multiply both sides by 3. That cancels out. So OA equals 18. That's how you do it. So just simply, whatever the missing number is, we know we're multiplying or dividing based on whether we're doing a reduction or an enlargement, okay? Lastly, number 10, OA equals what if OA prime equals 18 and K equals 1/6? And K equals 1/6. All right, so OA equals 18. So again, we're going to set this up like we just did the previous problem. So 18 equals, what did I say it was? 1/6 times OA. Simply multiply both sides by 6. So OA equals 108. So again, if we're doing a reduction, obviously looking for, we could find either line segment, we could find K, just find a missing letter. Again, if we're just simply moving, doing a reduction, or we're doing an enlargement. All right, let's look at number 11 here. Number 11, all right? So number 11, we're going to do, okay, so K is 1/3. So K is 1/3. So if K is less than 1, are we doing an enlargement or a reduction? We're doing a reduction, okay? So let me, all right, we have A, B, C. Okay, here's O. So K is 1/3. We're doing a reduction. So what's the first thing we want to do, class? We want to draw line segments to O. So let's draw line segments to the center point there. All right, very good. Once we do that, now we're going to, since we know it's a reduction, so K equals 1/3, we're going to measure each line segment, then multiply that by 1/3, and that will give us our answer, okay? So 11. So for number 11, we've got to measure. Now, again, my line segments are not drawn to scale, so I'm going to do it in the book, okay? So looking in the book, so line segment OA would be 2.5. So 2.5, let's just say that's 2.5. We're going to times that by 0.33. Now, I don't have my calculator on me or anything like that, so simply going to do this to here so we can figure it out. All right, so all right, I have 8.25, all right? 8.25 there. So, oh wait, how many? 3. So I'm sorry. So, (2.5) times 1/3, right? What do I got? I'm sorry. 5, 8. Okay, 0.825, right? I have that 0.825. So now you're going to simply just take your measurement. Again, I don't want to draw mine on the board because mine is not the scale. If I were to do mine, it's simply, I have 11. So a half of 11 would be 5.5, so 5.5. So that would be my point A there. So you're going to have to do your measurements. Again, my measurements are going to be a little bit different than yours on the board in your book. So I will show you what it's supposed to look like. All right, I'll show you what it's supposed to look like. All right, so... All right, 4. Again, we're looking at, I'm sorry, we should do this by 1/3. Okay, and there's my reduction there. So yours will be a reduction. So make sure you understand, measure your line segments. Once you measure your line segments, you're going to multiply it by 1/3, and then you'll get your new measurement, and then plot your points there, and you have A prime, B prime, and C prime. So be sure to make sure you follow that through and do it accurately. Again, mine is a little bit different because I'm not to scale. All right, let's look at number 12 here. Okay, number 12, K equals 2. So if it's greater than 1, we know it's going to be an enlargement. All right, so we have A, B, C. Okay, we have O right here. And so, again, this is kind of the same idea. You're going to draw line segments through each point here. I'm just going to extend these longer. All right, now, take your measurement. Now you want to measure from O to A, okay? Measure that line segment, O to OA, right? Measure that. And whatever you get, you're just going to simply multiply it by 2. You're going to multiply it by 2. I have 1.5. I don't know what you have on your calculator, or on your ruler. So 1.5 is what I have. So if you multiply that by 2, we should get 3, right? 3 inches there. And so you would extend that. So you'll measure that and then plot your A prime on 3 inches. And then work your way around each one. So mine would be 7. All right, so 7 times 2 would be 14 there. So we're going to call that A prime. All right, and then we're going to do the same thing with B here. So from here I have 5. All right, 10. Call that B prime. All right, and then we have C. So A to 1 there would be 8.5. C, and then you'll see here how we have an enlarged triangle. So that's simply how you do it. You got to make sure you measure, and you're either going to multiply by whatever K is if it's an enlargement. You're going to divide by whatever K is if it's less than 1. All right, you could do 13 and 14 on your own. 13 and 14 on your own. And then I want you to do today the checkup, page 41 and to page 43. 41 to page 43. Do the checkup. Again, be prepared. We'll come back tomorrow and just quickly review over the self-test, making sure everybody has an idea. The self-test will be taken on Thursday. So be prepared to take the self-test on Thursday. All right, thank you so much. Have a good day.